I'm Dr. Margaret Kelly. I'm here to talk to you about my project today.
Okay.
Yes, so my project, which is very generously being supported by the Alberta Lung Association, it deals with asthma and remodeling in the airway. As we all know, asthma is increasing in incidence. It's becoming quite a large problem, both economically and for individual persons. And my focus in asthma is looking at the remodeling that occurs in the airways. We believe that the remodeling is responsible for a lot of the symptoms and signs that asthmatics have. So one of the problems with asthmatics is that they get airway obstruction. And in older asthmatics, this gets worse as well. The obstruction is temporary, but then it becomes permanent. And we believe that a lot of this obstruction is related to a process called airway remodeling, which is where within the airway there is an increase in various cell types, one of which is smooth muscle and connective tissue type cells. And one of the cells that is responsible, and it seems to be the orchestrator of this, is the myofibroblast. I've done previous studies where we've shown that myofibroblasts are increased in the airways after allergen challenge, which is a kind of a model for asthma. So we take mild asthmatics and we expose them to allergens that will cause their asthma to be exacerbated. And after that we take bronchial biopsies. And I've looked at a lot of these biopsies and have noted a vast increase in the numbers of myofibroblast present. Myofibroblasts are cells which are found in scar tissue. So when you see somebody with a wound on their skin that's looking kind of contracted and bumpy and hasn't healed properly yet, that's a case where you've got a lot of myofibroblasts present. And the airways of asthmatics are actually full of these cells. And I believe if we can find out where these cells are coming from, how long they stay in the airway before they change into different types of cells, we will have made a very big inroad into the cause of asthma, and also will be better equipped to try and find drugs that stop this occurring. Well, the Lung Association has funded me before, so they've really helped me tremendously with a mouse model of asthma that I've used. This particular project now is supporting the cell culture side of this project, where we're taking cells from people who've had asthma, with and without asthma, and we're looking at how these cells respond to allergens, such as the house dust mite. The Lung Association is helping me with support for technical staff, for me to help me with these projects, reagents. These reagents are very expensive. We use a very purified sample of house dust mite, which is extremely expensive. All these cell culture media and reagents are also extremely expensive. So if I didn't have the support, I wouldn't be able to carry on with this research.
You want to give to the Lung Association, I guess, what would you do, or what would you be able to accomplish if you had like unlimited amount of funds? Like what would that do for you?
Well, unlimited amount of funds, that is something that I don't really think very much about, because I'm so focused on trying to eke out every single cent has to actually produce some effect here. So we're very, very economical with everything, and we try to do everything in the cheapest possible way, not take shortcuts, but try to be most effective. We try not to run experiments that waste time and effort and money. If we had unlimited funds, I would actually apply exactly the same stringent criteria, but I would then have more technical staff and could do more work and could get through the work faster. At the moment, I have one technologist running my cell culture experiments, and she's working full-time on that. We could go a lot faster if we had a master student. I'd love to be able to get a master student or a PhD student to be able to help support this work. We could just go that much faster. We could also support other aspects of this research. Part of this project, which is part of a bigger project, is that I'm looking at taking bronchial biopsies again from patients with asthma. So volunteers with asthma will be getting allergen challenge, and I'll be doing biopsies I won't personally be doing the biopsies, but we'll be getting biopsies from these patients at different time points. Now, this previous study I did was 24 hours after allergen challenge. I'd like to look as early as 6 hours after allergen challenge to see if these myofibroblasts are actually arising from the smooth muscle, we can see where they're coming from. We've got various techniques to do that. Nobody's actually done this experiment before. And then I'd like to look later on and see what happens to these myofibroblasts as the weeks progress. And this is a very expensive study, to get coordinators, to recruit patients, to get the patients in, to have all these various tests done, all the safety tests done on humans. It's obviously a lot more expensive than, say, mouse or rodent studies that we do. But I think that's a very important study because there's no actual model that truly models asthma. Cell culture, we're trying to model asthma in cell culture. We use human cells, which is a good advantage. A lot of researchers are using animal models, but there is no animal that actually has asthma as such. They have responses to allergens, but they really don't have asthma as humans do. So we're trying to cure asthma in humans. So I think it's really important to get funding just to fund these studies in human subjects and to learn from what we can learn from human subjects. Hello, I'm Dr. Kelly and I'm powered by breathing.